Hello everyone, welcome to the GoInsight.AI Quick Start tutorial. If you are new to GoInsight.AI and want to get up to speed on how to use our product, then this video is your ultimate guide. We will walk you through a step-by-step hands-on demo with easy-to-understand use cases, taking you from 0 to 1 with GoInsight.AI to help you rapidly adapt AI automation to your specific workflows. What you are looking at right now is the GoInsight.AI Insight Flow interface. Let's start by creating a workflow. We will use an interactive flow as our example. Enter the name for this workflow, then click OK. This takes us to the orchestration page for this workflow. You can see there are 3 default nodes: the Start node, LLM node, and Answer node. This setup is actually enough to achieve a basic AI Q&A effect. In the model option of the LLM node, you can select the AI model you wish to use. We provide a very rich selection of AI models adapted for different tasks. You can make your selection based on your specific requirements. In the System section, you can define the AI's persona and the instructions it needs to execute. For instance, here is the instruction we are providing. The User section represents the instructions, questions, or any text you need to provide to the AI. Here, we will use query, which represents the user's question, as our example. We insert this variable into the user field. And just like that, we've built a simple, fast Q&A workflow. Let's test the conversation results. After inputting a greeting, we can see the AI replies to our greeting. Next, we ask for the distance between New York and Washington. You can see the AI also correctly replies to the question I input. So, a simple interactive flow is quickly built and it delivers solid results. However, in this workflow, if we need to ask a question related to real-time data, for example, if I want to know what the weather is like in New York right now, you can see the LLM node prompts that it cannot provide real-time weather updates. This is because the LLM node is based on the knowledge the model has already been trained on. It completes semantic understanding and content generation based on the user's input. The LLM itself does not have the capability to connect to external real-time data sources or fetch dynamic information. So, when facing questions that require real-time data support, it cannot give an accurate answer. Therefore, if we want this workflow to have the capability to search the web for real-time information, we need to add a corresponding search tool in the workflow orchestration. Next, watch how I add a tool to the workflow. We will stick with the real-time weather query example mentioned above. First, let's modify the system content of the LLM node. When the user asks weather-related questions, do not output the answer directly. Instead, let the LLM output content in a specified format. So when we ask, "How is the weather in New York again?" the LLM will output, "I need to check the weather for this city, New York." This is the specified format we asked it to output. Our other questions remain unaffected. Next, let's add an if or else node to the workflow. This node is primarily for logical evaluation based on input variables to determine the direction of the subsequent workflow branch. Here, we set the input variable to be the output variable text from the LLM node. And we set the logic if this variable contains "I need to check the weather for this city." It will follow the if branch. Otherwise, it will directly output the reply. In the if branch, I am adding a Google search tool. The search keyword for this tool will be the content output by our previous LLM node. Let's briefly recap. If we ask about the real-time weather in New York, the LLM node will output "I need to check the weather for this city, New York." This segment of the answer will also serve as the keyword for the Google search tool, allowing the tool to perform a real-time web search. Here, we place the output variable of the Google search into the answer node for direct output. Let's show you the search results. We will still ask a question first. The AI answers normally. Now, let's ask the question about the current weather in New York. You can see we obtained the Google search result for New York weather, but this result is very long. Ultimately, we want the workflow to answer my question directly, rather than just showing me search results. So, we need to add another LLM node after the Google search. This is used to combine the search results and the user's question to output a synthesized answer. In the system of this LLM node, we fill in instructions to let it output an answer based on the search results and the user's question. And in the user section, we insert both the user's question and the Google search result as variables provided to the LLM node. Finally, we modify the output variable in the answer node to be the output variable of this LLM node. Let's check the results. You can see the workflow successfully gave me a reply regarding the real-time weather in New York. With this design, we can successfully call tools based on user intent within a single workflow, completing a real-time search task based on the user's question, and finally providing a reply. However, you might notice that the process above is slightly complex. We actually have a more streamlined way to achieve tool calling effects. This brings us to our agent node. The LLM node is best suited for executing single-step reasoning or content generation based on user instructions. In contrast, the agent node is designed for multi-step tasks capable of autonomous decision-making and utilizing the appropriate tools. Operating within the constraints of your instructions, it autonomously plans the execution steps and selects the right tools from your provided tool list. It can automatically populate the required input parameters for those tools and generate the final response or execution result. Essentially, using an LLM node requires you to manually orchestrate the workflow. However, with an agent node, the system automatically orchestrates the process based on your defined task. Now, let's take a look at the agent node configuration. In the configuration page of the agent node, just like the LLM node, you can select a model. Additionally, you can add various tools and apps to the agent. We will still use that real-time weather query requirement as our example. Using the agent node, the entire process becomes very simple. We insert the Google search tool into the agent's tool list, giving the agent the Google search capability. In the instruction, we assign the agent a persona and corresponding commands. You need to answer the user's questions. If a question is time-sensitive, you may call the search tool and respond to the user only after obtaining the results. And in query, we insert the query variable representing the user's question just as before. With that, the agent configuration is complete. Then, we use the agent's output directly as the final reply. Let's look at the effect. We input a greeting as usual, and we see the agent can reply. And when we ask about the real-time weather in New York, the agent calls the corresponding tool and provides the real-time weather result for New York. In this process, we can see the agent autonomously decided to call the tool based on the user's instruction and question and outputted an answer. Based on the cases above, we find that the LLM node possesses basic semantic understanding and content generation capabilities, but it requires manual orchestration of the flow to achieve tool calling. The agent node, while inheriting the core capabilities of the LLM, supports autonomous judgment based on user questions to call configured tools. There is no need to manually build branch logic, achieving a much cleaner tool calling process. It also lowers the difficulty of building workflows. GoInsight.AI also provides users with a rich set of tools and apps. Combined with the agent, this can satisfy many user work scenarios. Next, let's quickly build an email assistant to help me check emails. we add a new agent node. In this agent node, we select Get a Mail and get many messages from the Gmail app. The specific capabilities of the agent depend entirely on the tools you include in its tool list. For instance, if I only provide an email query tool here, the agent won't be able to perform actions like sending or forwarding emails. The agent can only invoke the tools you have explicitly authorized. Then set up the corresponding credentials. Regarding input variables, the agent node will automatically populate them for you based on the task requirements. You also have the option to define specific default inputs if needed. In the instruction for this agent, we define its persona and task. Just like that, an email checking agent with a live connection to your Gmail is built. Now let's ask it to check what new emails do I have. You can see the agent is thinking, and it calls the corresponding tool. As you can see, it successfully queried the recent email content from our Gmail. In addition to the massive library of apps and tools GoInsight.AI provides for users, we also support users creating their own tools, which can be provided to an agent or used directly in a workflow. This means you can turn APIs, code, or reusable personalized requirements into tools, combining them with AI capabilities so that other members within the enterprise can also use them. Next, I will introduce how to create custom tools. We will create a tool that can output the company introduction for Sand Studio as a demo. We go to Services and Tools in Insight Flow, click Create Category to create a tool category. After that, we click Create to create a cloud-side tool. Input the tool's name and description. It is important to note that the tool's description is very critical, because if this tool is to be provided for an agent to use, the agent will analyze this description to judge whether it needs to call this tool. After that, we select the corresponding category and click Create. On the tool orchestration page, add a template node. We select the GoText template syntax. Then, we add the company introduction for Sand Studio. In the end node, we set the corresponding output variable, which is the output variable from the template node. You can also add a description for the tool's output variable. This helps the agent or others better understand the usage scenario of the tool when using it. Once we test that the tool fits our logic, we can click Publish Tool. We need to fill in some fields in the tool settings, such as tool name and usage example, as well as descriptions for input variables and output variables. In this tool, since we have no input variables, this section is empty. For the output variables, we include the introduction of Sand Studio. I need to remind you, when the agent calls a tool, it references the descriptions of the tool's input and output variables to autonomously think and decide whether to call the tool or to populate the corresponding variable fields of the tool. So, the description of the tool itself is very important. Once we finish filling this out, we can publish the tool. Afterwards, in the editing canvas of other workflows, we can find the custom tool we just published. Published custom tools can also be called within an agent's tool list. We simply configure the agent and add the custom tool we just made. Next, let's run it and see the result. Let's ask, what are the business scopes of Sand Studio? You can see the agent autonomously called our custom tool, retrieved the company introduction for Sand Studio, and summarized the answer for output. Alright, that concludes the quick start demo for GoInsight.AI, from basic Q&A and tool calling to the efficient use of the agent node, and finally, the construction of custom tools. Feel free to follow along with the hands-on demo and give it a try. Combine it with your own work scenarios and expand flexibly, and you can easily build your own exclusive AI workflows. More usage tips will be continuously updated. See you next time.